So, and it's probably the outlier in the, put them back in. Now I'm doing a three-dimensional plot. Never done this in this class before. Is this going to help? It's got the okay. I don't think I'm going forward with this plot. This is some attempt at an ellipsoid over most of the data. But then there's some weird, so what the heck are these things? Those are how the stickers up on the board, who knows? So this is what you can do with a 3D plot. You can look at it from different angles. Let's see if I can take off the. It wants to do the ellipsoid. I should, and I'd rather take off the coloring. But anyway, the point is that you can look around and see. There's the view down the. What kind of shape do I have here? Some kind of saucer type thing. How about that? And being able to look at it from different angles allows you 3 dimensions to see sort of what's going on. Maybe I'll figure out how to make the ellipse go away. But you can. I've never put it in paint. You could though, and especially in an online journal, you can do it. All right. As we continue our experiment, let's see if this is the one weird data point, right? And that was that one point, maybe. Yep. It's the same one that pops out here. It's got an odd value for TI and an odd value for U, and it's got a normal value for V. So if I take it out, so it becomes a philosophical question, right? Gone. Analyze. Oh, this is with the logs. I don't want logs. Let's see how many logistic regression does first. So I got rid of one data point that I didn't like. Why did I get rid of it? Because I felt like it. Is that justified? No. I should make the confusion matrix the default. I still didn't get any better. You would have thought, right? That we'd get better. But no. No better. That outlier does muck with the multivariate normality, seriously, right? So maybe the discriminant analysis will get better. And I want the origin variable there, and my other 3 variables there. Oh, it classified the one. It's an interesting, the, here's the data that I used. The one that I excluded, the one left that I excluded, it classified as, it's actually from Kentucky, but it did put it from the US. So that's why it went from 3 to 2 there. Oh, I'm not doing any better. What should we publish? Probably the logistic regression results. Maybe we should use more of our data. Let's see. I guess the point is that there are multiple methods for discrimination, and if you're in that category, then you should consider all of them. And there's no right or wrong answer to what you should use. The trouble is that when logistic regression doesn't work, you may want to have alternatives. And these are the people that come to us with, my logistic regression doesn't work. Well, maybe your data is just a mishmash of nothing. But typically there is some structure in there, and looking for it with LDA or PLS is helpful sometimes. Now let's go back to we have a few minutes left, so we're going to go back to the original data. So with 4 groups, quickly, what happens if we give it the same 3 variables, but we have 4 groups? Oh, I don't have my color turned on. Half the fun is to have color. Color marked by column, and we want the origin variable. Doesn't matter which or which. You can change them, by the way. And in reality, you may want to use a different color scheme. And here's the kind of plot that you may want in your paper. Here's the red ones, the blue ones are over here. We're having trouble differentiating between Kentucky and the US. So is that a better plot? And so you get your point across. Should we use PCA instead? Should we, hold on. Analyze multivariate discriminant, recall. But this time we allow the covariance matrices to be different from each other. To me, that looks a whole lot better. You get to decide. You make the decisions for your data. But it definitely gets, the red ones really are long and skinny. And the blue ones are up here. And these are 2 different angles. Look at that guy out there. Green must be Kentucky. That point's not that odd, given the fact that the green guys are like that. So that point appears to be an outlier, but not really, maybe. Because it's in the direction of the spread of the data goes like this. Without that point, it'd be much different. Again, those 2 troublesome points keep popping up. So that's a plot that might go in your paper. If we do, we've done this before, but the principal component one, multivariate principal components. not as nice. Do we see? Yeah, you still basically get the same point across, right? It's making linear combinations in both methods, right? But the discriminant analysis is optimized to discriminate between the groups, and it does a better job. It's still showing you that there's overlap between the groups. If someone came to me with this plot, said, it's not this, I'd say, well, let's do the LDA plot, which it's got to do better because it's using the fact that the groups are different from each other. Let's see what happens if we do I'm not sure what jump is going to do with this. So this is all. This has 4 groups in it. I have no idea. Like, let's see. The way that, and maybe I should give a whole lecture on this.